Okay guys, welcome back to number 7. So, what do we have here? So, for this kind of question, I actually cropped out most of the information because to be frank, this is quite straightforward and it's good to just have a look at the key points over here and just to use the relevant stuff. So, let's check out part A. So, first things first, we need to draw a scatter diagram of these data on axes provided. And alright, so we got B and P. So, B I believe was blood pressure or BMI, and P was probably pressure, one of them. Now, this is easy. You just follow the B axis, the X axis. So, for example, for point A, we'll put 32 across. And notice that these blocks are going up in twos. So, we've got 32 here, and it's going to go up all the way up to 18. So, it's here. Same thing for the rest. So, you're going to be plotting all of these points, which is very straightforward. And now, the main thing to notice is that when we get to point H, is that H is completely off. If you look at the P value, it's extremely high. So this one is what we call an outlier. So I'm just going to label this second. And this one came all the way over here. So that's how it looks. And just FYI, this is all from the mark scheme, yeah? So at least I can definitely say that this one is 100% correct. Now, let's look at the next following bits. So the doctor decides to leave out patient H from his calculations. So give the reasons for the doctor's decision. Well, given that H is over here, we can clearly say this is an outlier. So any point that falls way off the mark, we call it an anomaly or an outlier, so it doesn't fit the general trend. And usually, or depending, sometimes the data can be included or excluded from calculations. Okay, let's move on. So for the 7 patients, A, B, C, D, E, F, and G, so excluding H, the following statistics were given. So we got SPB, SPP, and SBB. Okay. Now find the product moment correlation coefficient R for these 7 patients. So the R value is very standard to calculate. Usually we use it with SXY and SXX. In this case, for R, we're going to treat B as X and P as Y. So I put the equation up here and I solved it. So it'll be R equals SBP, and that cropped out, over the square root of SPP and SBB. BB. So plug all these values in and you should get a value of roughly positive 0.81. So this indicates, so when a value is like this, if it's close to 1, we call it a strong positive correlation. So it's quite a strong correlation. So this is actually the value here. And if you look carefully, it does look like a strong correlation since all the values are very close to each other. So extremely positive. Now, finally, D. Without any further calculations, state how R would differ from your answer in part C. Now, this is either you understand or you don't. So, with an outlier, if an outlier is included, this automatically kind of ruins the flow of the points. So, the correlation will be actually reduced. It will probably reduce closer to 0. I mean, it won't be 0, but the value will be reduced. All because that this anomaly does not fit the pattern. If this anomaly was, however, somewhere over here, it may even get, the correlation might increase. So whatever point is closer to the line, at least if it's close to the general line, then the correlation would increase and will fit to it. In this case, the correlation might slightly bend across and be like this. Or perhaps it might even get worse and have no correlation. Anyway, that's literally it, and I hope this helped. And let me know if you need any more questions solved or any general correlation regression problems. Other than that, see you soon. Ciao.